All right, we're gonna go ahead and get started. It shows 2 o'clock Eastern time for me here. So, hello everyone, and thank you for joining us for this live presentation for Balluff's automation launch. My name is Chris Duncan. I'm the trade show and event specialist for Balluff, and I will be your host for today's live presentation. I'd like to take a moment to remind everybody to please, after this presentation, further explore the Balluff Automation Launch Virtual Exhibition Room to learn more about the latest manufacturing technology that will make sure that you are prepared for 2021. And chat with our Balluff experts that are on hand, staffing the virtual booth with any questions that you may have. A few housekeeping items before we get going, just to make sure to enhance your experience. First off, for the best viewing experience, we recommend closing any extra programs or browser sessions running in the background that could cause issues. Streaming live presentations is bandwidth intensive, so closing any unnecessary browser tabs will help conserve your bandwidth. For those of you that are watching this presentation live, if you have any questions throughout the webinar, please submit those using the Q&A chat window, and I will gather those questions throughout the webinar, and there will be a Q&A session with the presenters at the end of the presentation. We will try to answer all of the questions that are asked, but if a fuller answer is required or if we run out of time, please know that we capture all questions and we will contact you via email. If you think of a question after the presentation ends, please use the group chat feature on the virtual exhibition platform. Our presenters will be there throughout the week, as well as other Balluff experts, and they will be able to answer your question there. For those of you watching this in the future, please use the Contact Me After This Event button inside the virtual exhibitions to send us a question via email, where we can respond to you via email. A copy of the presentation slides are available on the box.com link that I put into the Q&A chat box there. So if you would like to follow along with a PDF version of the slides, you can download those there. And for those of you watching live, an on-demand replay of this presentation will be available through the platform tomorrow. And if you need if you would like to watch that sooner, please get with me and I can get you the link immediately following this. Our presenters today are Wolfgang Kratzenberg and Logan Welch. Wolfgang is Balluff's technical sales specialist for RFID and traceability. Wolfgang has worked at Balluff for 8 years. He is an experienced sales and marketing specialist focused on RFID and barcode technology. Wolfgang assists in every phase of a traceability project, from idea to implementation. He has a passion for making a complex concept easier to understand and is focused on helping clients achieve their organizational objectives. Our other presenter is Logan Welch, and Logan is Balluff's machine vision technical sales specialist. Logan Welch has more than 20 years of experience in the industrial electricity, factory floor automation, automation sales, renewable energy design, and machine vision. He has held roles as a controls engineer, a territory vision / ID sales manager, and an engineering manager, among other priors to joining Balluff's vision team. Logan prides himself on being a collaborative resource in any role he is in, and he is always passionate when talking about the benefits of Balluff's vision solutions. Without further ado, I'm going to turn it over to Wolfgang, and then we'll get to Logan to finish the discussion. Please enjoy Driven by Data, the role of RFID and machine vision in the assembly and production.
Thanks, Chris. So the title of today's presentation is Driven by Data, and I'm not here to tell you that you should be driven by data. I think you all know that by now. The key, though, is how to be driven by data. Is how do you take that data, how do you collect that data to make the complex decisions that you have to make as a manufacturer every day? So That's really what we're going to talk about today. We're going to talk about it from an RFID perspective and from a vision perspective. And I'll repeat this multiple times today. And when you think about a traceability project or a quote RFID or a quote barcode project, it's not really a question anymore of RFID or barcode or RFID or vision. A majority of the time, it's going to be a combination of both. It's going to be RFID and vision working together for an inspection application. And again, we're going to go into this later, but it's usually a combination of all those technologies. And that's where it can get a little bit confusing, but realistically, once you hammer it all out, it's pretty straightforward and logical. So let's jump in here. So, you know, all the areas of a plant, and this could be any plant. This could be anything from an automotive plant to, you know, insert any industry plant here along the way. But for sure, a vertically integrated plant in one setting for sure. So let's just go across the top. You think about like injection molding machines, you know, anything in the plastics world. So, you know, two-shot molding as well, machining centers, metal forming, meaning stamping, and then even when you put the tools away in the tool room, you have a location where the tools go when they're not in use. RFID has a role in all those areas. And you think about, you know, where would it play in the injection molding world? A mold is just a tool, right? I mean, it wouldn't matter, you know, some tools are very small, some tools are very large. In this case, most injection molds are fairly large, and then the inserts that go into them are fairly small. But all of those things need to be tracked. And it's just not that they need to be tracked, but what information can you put on the tag, which goes on the mold itself, that can help you make decisions in the future. And that's the key. And things like how many shots, that's a huge one I know for sure in the injection molding world. In the machining world is how much tool life does a tool have left on it, right? So if I have a milling tool in there and I require 3 hours of work for that tool and it only has an hour rated of work life left, well, then I probably shouldn't be using that tool. I should go find one that has a longer life than 3 hours. Metal forming, you know, you think about, you know, these gigantic dies that go into to very large presses. I've seen some big monsters out there, and what guys are doing is they'll put the tag on the actual die itself, and first and foremost, they're trying to make sure that they have the right die and the right press. You wouldn't believe how many times, or maybe you would, how many times the wrong die gets put in for the wrong application, and shut height is off and all that. And what happens when that occurs is you have a crash, and a crash in, you know, a 600-ton press is something to reckon with. So it's used in so many different ways. And again, it's how that information is important to your organization. All this information is about how you need to use it. RFID tag alone is just a piece of memory, and you can write as much or as little information on that tag as you'd like to. And again, in the tool room where the tools are getting put away, shipping and sequencing, this is really big in the automotive industry, especially the sequencing side for just-in-time delivery. When a tier one loads up, let's just say bumpers for a car, and they're shipping them out to the assembly plant, those bumpers are loaded onto the truck in the order that they're going to come off. That way they don't have to go to a storage room. They don't have to sit there for a couple weeks. As soon as those bumpers come off the back of that truck, the first one that comes off is going to go on the first car that's on the line right away. And you do that with RFID and barcode together. Material flow, or what we call e-Kanban, essentially that's just automated replenishment. Also in the receiving area for raw materials coming into a plant. So, you know, no different than you have your finished goods going out one side to go be shipped. On the receiving side, you have to be able to identify where that raw material is when you want to use it, when you want to start the production process. So today I'm going to focus mostly on the automated assembly side. And this is a critical area because this is one of those places where you can use literally just a license plate of data, a very simple, let's just say a 4-digit number on an RFID tag, or you can write reams of information. I mean, literally up to 128 kilobytes of data can be written to a tag throughout this process. And I'll tell you why you may write that much information to a tag here shortly. But again, we'll focus mostly on the work in process application today and how RFID and vision solutions are used there. But again, it can be used all around the plant. So from a traceability standpoint, there's a ton of different ways to address an application. And, you know, what I always say to customers, to our sales team, to our distributor sales team, is the application will drive the technology. You'll never see us coming in and showing off the latest and greatest product unless you have an application that fits that latest and greatest product. That's just not the way that we address applications. And the key here is, and I'll go over this at the end of the presentation, is what are the things that drive individual product selection? You know, and a big part of that is throughput, how much data and how fast. Another major part of that is your environment, right? Your architecture plays a big role in that as well, is what are you trying to accomplish overall? So a lot of times that's the first question that I'll ask, even going in as the RFID specialist. I don't just want to know what role RFID is going to play. I want to know what you're trying to accomplish overall, because again, Balluff is a full automation company. We do sensors, we do measurement devices, we do cables, we do networking, vision, of course. And so we try to get that big picture concept. That way, when we go in and talk about a specific product line, we need to think of it on how it can be addressed from an automation standpoint, and not just, you know, looking at it through a microscope. We have to take a step back and look at it. So that being said, there's a lot of different ways, even within RFID, to address the application. We have a 4-port system that actually has an IOLink master port on board that's designed for really fast, really high data intense processes. Very simple 2-port system. I'll talk a little later about our IOLink RFID system that's really designed to do your license plate type reading. Our point-to-point or all-in-one system has gained huge popularity lately because of just space constraints on the production line. And then there's our long-range RFID, usually the UHF side, that customers are using for more flexible manufacturing, because maybe you have a part that's going down the line that, you know, or you're manufacturing 2 different things on one line, and you have one part that's smaller than the other. So that read range will change when you switch those parts out. So in order to be more flexible in that read range, they'll choose a RFID system that has the capability of reading close and a little bit farther away. And then, of course, there's barcode reading, and there's handheld barcode and RFID reading as well. So we're going to get into all this a little bit later here. So 4 major applications within a manufacturing plant, and it really just doesn't matter. Again, it can be manufacturing a vehicle, you're manufacturing, you know, wafers for semiconductor, or medical devices for life sciences. Really, all of these things come into play. There's always asset tracking, and these are plant-based assets. I'm not talking about your IT equipment and that kind of thing. We're talking about things that are required to build the product. Is what are the tools that are required? You know, what are the change parts that are required when you do a change out, or when you do a changeover, when you change from making one part to another? Those are the assets that you need to be able to identify those and locate those when you need those. RFID plays a major role in there, and it's no different than Kanban. And Kanban actually comes from the automotive industry, but it's also used in just about every other industry out there, because at some point along the production line, if an operator stocks out of a part, well, you have to have a way to get it down to that operator so he can continue to build those parts. And then the one we're going to talk about mainly is production control. We'll go through that here shortly. But another big one nowadays is intralogistics. And a lot of people, when they think of RFID, they think of, you know, tracking shipping containers, you know, across the seas and stuff like that. But realistically, the major way that RFID is being used more than the most use cases is tracking material. And this goes back to what I was saying about the raw materials as it comes into a plant. Tracking those raw materials from start to finish. Again, you know, I need to know where that raw material is when I need it, because otherwise it's going to slow me down. And again, downtime is not a good thing. That's exactly what we're trying to eliminate in a production process. So, you know, it could be things like, and I've run across this application multiple times, is you have a temperature sensitive material that has to be in cold storage, and when it comes out of that cold storage, it needs to be you can only keep it out of that cold storage for a certain period of time. You can track and log that information on that RFID tag to make sure your operators are fully aware of how much time they have left before this thing needs to go back into cold storage. So the key ROI elements, and this is just specifically for a work in process. So, and this is RFID, this is barcode, this is a combination of RFID, barcode, and vision, machine vision for that matter. So again, it enables flexible manufacturing, meaning, you know, the days of producing one product on one line, it's unheard of. You know, the key is being flexible. So when you want to change that line out and make it available to carry the double size products, or let's just say in the packaging industry, if you're going to switch a line out that makes 16-ounce boxes of cereal to 32-ounce boxes of cereal, you have to have, there's parts that have to be changed out. There's things that have to be adjusted on there. So, you know, how do we do that? And again, a big part of that is what your specific application is. Everybody does not do this the same. I can tell you that from years of experience of being in hundreds of manufacturing plants. Everybody has a different way of doing it, again, because it's designed to fit their application. A big part of it as well is tracking the rework process and being able to get something into that rework process as soon as possible to eliminate downtime, or for that matter, eliminate scrap. Because there's sometimes when, you know, you make a mistake on the production line, something is better off being thrown in the scrap pile than it is to actually go through the entire rework process. So we'll talk about that. And handling recalls. Again, you know, this is a big one when you think about, you know, the old days of, you know, they get on the national news in the evening and say, hey, all 1979 cars are going to be recalled in this model number, and, you know, everybody has to go back into the manufacturer and get this new product put, or get this new part put on. Nowadays, they can identify it all the way down to the VIN number, so they know exactly who to contact. There's not this broad scale recall, but that really, you know, damages the integrity of the brand as well when you do that. So, and again, a big part of this is also maintaining regulatory compliance, is making sure that I have traceability. I can say that this product has been, this is where this product started, this is where this product is, and this is where this product is going. That's the whole concept. And you can answer all those questions, and RFID, barcode, and machine vision allow that to happen. It allows you to be able to record that data, and you have a record of it in case you need to show that record. So this is what I was really talking about before, is, you know, everybody knows we should be driven by data, right? It doesn't matter if it's in our personal lives or anything else. We're as smart humans, we need to make decisions based on real, reliable data. That goes without saying, I think. But so what is the data, right? Is what kind of data is being written to an RFID tag? And in some cases, people just think of like, well, I write a 4-digit number on there, and that gives me full traceability. I scrub it against a database. It tells me exactly what that product is, et cetera, et cetera. That's fine, and that's absolutely a way to establish traceability, and that's usually an entry-level way to do it. But we have the capability, because of our tag size, because of how RFID in general has evolved, especially over the last decade, we have the ability to write a ton of information to these RFID tags. And the question constantly gets asked of me is, you know, what are they writing? What are people writing to the tag? Because what we've seen is, like I said before, there's an evolution that's happening where it's not just barcode or RFID, it's a combination of both. So the people who are familiar with barcode, they understand that you're just reading a barcode, you're reading a few digit number, and you're scrubbing that against a database. Again, with an RFID tag, they don't realize how much information. You can write a story on that RFID tag if you wanted to, up to 128 kilobytes, which doesn't sound like a lot in the world of PCs, where we are nowadays. But the reality, that's like 64 pages of text, right? So that's a lot of information, and I'll talk about where that can be used here shortly. So these are basically the 3 kinds of data that are written to the tag, written and read as well. But this is the kind of data that manufacturers are using today to improve their process, to eliminate downtime, maximize uptime, increase line speed, all the things, all these words that we hear all the time as we go into manufacturing plant that we're asked to help do with automation. So what is build data? Essentially, it's just what you're trying to build. And I'm going to give specific examples here shortly. It's what are you trying to build, right? So in station one, you may have, a pallet with one piece of raw material of what this thing is supposed to be down the line. Well, to an operator, it's just a raw material. You think about, the seating, the automotive seating industry. You come through and you may have the base of a seat. Well, what color is the base of that seat? Does the seat have a heater in it? Does the seat have extra lumbar support in it, et cetera? So we need to know that up front in station one what this is supposed to have, because a lot of times it looks all the same. So you can use RFID to be able to help an operator identify exactly what needs to happen in that process. Process data, and this is the key. This is where I have a lot of conversations with my quality assurance departments, with continuous improvement departments, et cetera, is how well do we build it? And this is that quality information, right? This is where, did something have to go through rework? If it did, where was the problem? Was it station one? Was it station four? Is there something happening between station 3 and 4 that I need to fix? Right, so this is that data that gives you the power to make those educated decisions as opposed to taking a wild guess. And then the last one, lineage data, and you've probably heard of this a lot in the produce industry, especially with romaine lettuce. One of the reasons why there's widespread global recall of romaine lettuce is they can't identify specifically where the romaine lettuce came from. Again, sometimes they can track it back to a cold storage location, but what about going that extra level? What farmer did it come from? What field did it come from? What location in a field did it come from? All that is more information that will allow us to eliminate that broad scale recall, because I can identify it down to a specific area as opposed to making a widespread recall and everyone's losing multiple millions of dollars because of it. So again, I'm not going to talk specifically about the produce side of it, but I'll talk specifically about manufacturing and very, very similar processes that we can use to eliminate the problems of unneeded recalls. So I mentioned automotive seat manufacturing, and again, this could be any industry, but this is a big one because you think about all the different combinations. I think there's over 10,000 different combinations in several of my automotive customer plants that I've gone into. So many possibilities on the configurations of just a standard seat that goes into an automobile. But again, it's about writing that information to the RFID tag. I mean, tags can be as little as, we have a 6 millimeter diameter tag that's 1 millimeter thick. Something as small as a 8 millimeter diameter read head that can read the information that's written to that tag. So again, it's about knowing what this seat or what this potential part is destined to be by the time it gets to the last station on the production line. And knowing that ahead of time allows your operators to make those educated decisions along the way. Process data, and this is the big one I was talking about, is, so imagine you have a 50 station operation, on a production line, and very first station, like I said, it comes in with, just a raw part on a pallet. Every one of those stations is critically important when it comes to whether or not something needs to go to rework or to be scrapped. You think about this, think about all the value that would get added to just a case like this, to a washing machine, right? And if you look at this, you can see that it's not the same as the others. The one that's going down the rework lane has a tan bezel on it as opposed to a white bezel on it. Maybe they used a color sensor to kick that off the line, or to identify, hey, we have a fail here, so we'll go ahead and kick this product off the line. But you think about the problems that you run into if you don't have the ability to do that. Is all the information, so let's just say you had a problem at station 2 and you're going all the way to 50 stations. If you had a problem at station 2 and you don't find out about that problem until you get to station 50, there's a major problem, because all 50 of the products that's behind that one bad product, or something could be wrong with those as well. So if I can identify the problem immediately and then take action, I'm at a huge advantage. Otherwise, I have all the time and resources that I've put into a product that's eventually either going to go to scrap or have to go to rework at the end of the line. So again, it's about updating that data real time and making real time decisions along the production line. So lineage data, and this is the one I mentioned, the romaine lettuce example, but I mean, this is just a case of a simple fuel injector. And a dozen parts that we've identified here that we put barcodes on, and that was that little animation there was essentially what customers are doing in a case where they can't do full item level tracking with RFID, because let's face it, you're not going to get an RFID tag on that little red O-ring there at the bottom of the fuel injector. It's just not going to happen. So what customers are doing, they'll put individual barcodes on each individual part, and they can write those barcodes as it's being built. That barcode number can be written to the RFID tag, and now you have a part that sits on the pallet, and it doesn't have to sit on the pallet for that matter, but in this case it does. That big 90-degree shape you have in the middle is an RFID tag, and the information is written to that RFID tag. So instead of having to go up and read each individual barcode to identify all the parts that's on the fuel injector, I can walk up, I can read the RFID tag, and it tells me every single component that is on that specific item on that pallet. And again, you may have 4 or 5 different suppliers for each one of those parts. That's a reality. A single source supplier is rare. So again, if you have a recall, you need to know specifically where that part came from. I mean, something as simple as this little O-ring, if at some point they realized that the car was having trouble and they identified that it was because of the fuel injector, well, not only do they just have to replace the fuel injector, so now they have to go back to that manufacturer and say, hey, you sold us a part that's causing all our cars to be recalled. They can say, well, wait a minute, we can identify every single part that had the potential problem O-ring on it. So we don't have to recall every single car. Again, we can only go back to we can go all the way down to the detail of where that one single bad O-ring is, and we can identify who that supplier was and take corrective action from there. So again, you always use that produce example because it's sometimes a little bit easier to understand from a consumer perspective, is that how many steps does produce go through before it gets to our store, right? So by the time it's at the store shelf, it's going through an individual distribution warehouse, it's going through cold storage, it's going through the farm co-op, it's going through it's been unloaded on the tractor with other products, and it's been or it can be tracked all the way back to a specific field. Again, it's the same concept with any kind of a part that it's used to build, or any kind of component that's being used to build a finished good. It's the same concept. So a couple of different tracking options, and I mentioned this briefly, is that not everybody builds on pallets. It's just as simple as that. And in many companies, if they can avoid building on pallets, of course, that's just another asset to track, and they'll avoid it. But we can do it either way. Again, that's something that we've built a lot of modifications based on the fact that we have a specific customer that doesn't want to use a pallet. Well, therefore, you're not going to put a tag on a pallet, but we can put the tag directly on the part itself as well. It's definitely something that we pride ourselves in here at Balluff, is we're willing to identify, or we are willing to produce a application-specific modification that fits your application if it makes sense. So again, the tag can be on the pallet, it can be on the part, it can be on the carrier in some cases. I've seen cases where they've utilized RFID in paint shops, and they didn't want to paint the actual tag that was on the part or cause a part on the painted object to not be painted, so they'll hang the tag on the actual carrier that's going through the paint shop, and you identify that tag that's on the carrier as opposed to a tag that's on the spot on the actual item itself. So a lot of different ways to do it. So again, 2 ways to do this. There's thousands of ways in the end. I could say 2 or 2,000 different ways to address an application that involves automatic data collection in general. Basically, from a read and write standpoint, you have a fixed reader or a handheld reader. And again, it's about what fits your application. The good thing is that we can do both, and that's the key to keep in mind. The benefit of a fixed read, obviously, is that it's truly automated, right? No one has to pull the trigger to get a read. So it's true automation. The tag passes in front of the reader reads the tag, and the information is transferred. And once again, you don't have to depend on an operator in some cases to align the reader to the tag. So if it's a fixed reader, I don't have to worry about someone walking over and reading the wrong tag. Again, now the handheld side of it offers the mobility to do that. So let's say if you have a production line and you have to pull whatever it may be, 10, 15 parts off that line to do a special run for a customer. Well, after you get done with that special run and it's time to put those other parts back on that were on there, I have to be able to go identify what station was each of those parts in, right? So if I know something was at station 1, 2, 3, 4, 5, etc., I can put it exactly back on the production line where it was. I don't have to look at it and try to investigate and do research to try to figure out where to put that, because all that time that I'm investigating and doing research is downtime, and that's not good. So again, handheld, fixed mount. From a handheld standpoint, we can do LF, HF, and a UHF. Fixed mount side of things, the same way. Low frequency, high frequency, and ultra high frequency, and there's benefits to both of those. And I'm not going to get into the details of the technology today, but again, there's a time and place for every single one of those technologies. And again, that's really what gives us a huge advantage in the market, is that we have a lot of different ways to address a lot of different applications. Low frequency, as I mentioned, performs very, very well in a heavy metal environment, meaning you can actually bury the tags flush mount down in metal and get very good read range. Something you give up with low frequency is a smaller memory available, right? So up 192 bytes, which to some, again, that's plenty of memory to do whatever fits the process. But once you get to the high frequency side, it allows you a whole lot more flexibility when it comes to memory size. You actually go up to 128 kilobytes, as I mentioned before. So again, a big part of whether or not, do I use one frequency over the other? The key here is really, and I'll say this 100 more times maybe, is that it's what fits your application. That's the key here. You really don't have to inundate yourself with the ins and the outs and the bits and the bytes until you have to. And again, allow us to use our experience to explain why we would choose one frequency over the other. And then the ultra high frequency. And I put these three slides on here for a reason, because I have seen an evolution over the last decade from, you go to that really short range, couple millimeter read range maximum, to a lot of customers are saying, well, I've heard of UHF and I want to take advantage of those long read ranges, which is fantastic, because I mentioned before the benefits of being able to have that flexible read range is that now I can run multiple size products on one production line, which is what we're all trying to do nowadays. But again, there's benefits to when you would use UHF, because if I have to have a ton of memory, if I want to write all that quality data, if I want to take images from my camera and combine them with an RFID tag and be able to transfer that data quickly, again, all these things are things that must be taken into consideration. And a big one is environment for UHF. And again, it's not that they don't perform well in a specific environment. It's just that when it is, and let's just say a heavy metal environment, a lot of metal around, beams, etc., one of the things to take into consideration is UHF performs differently around metal than HF or LF does. It's just physics. In general, it's two different types of coupling that's used. So UHF uses electromagnetic backscatter. High frequency and low frequency use inductive coupling. So they have a different way of addressing the application from a physics standpoint. So again, there's a time and place for all the different frequencies. So I mentioned this earlier. I alluded to the fact that there's a certain group of information that we need to make a decision when it comes down to which system to use, which system to recommend, what's going to be best fit for the application. And these are the big ones right here. And maybe you could even just go from the bottom to the top. I think all my tech guys would agree with that, is that the environment plays the most important role. There's only, I'm not with RFID, I'm not going to read through metal. I'm not going to read through liquid. It's as simple as that. Now, I can actually, Balluff has a system that's actually optimized to read while the tag is on metal, but it's not going to read through metal. That's a physics limitation, not a limitation of Balluff. So again, it's very, very important. So to say, hey, you know, this tag with this reader gets, let's just say 3 feet in the case of a UHF, that's not always reliable to look at that in a spec sheet and say, well, yeah, I'm going to get 3 feet whether I'm in a laboratory or I'm on the production line. It's not the case. It's critical to know what that environment is like. And going back to the top of the list here is throughput. How much data and how fast do I need to read? So some manufacturing processes, the product comes into a station and it sits there for, let's just say, 5 minutes. You can read a ton of data in 5 minutes. That's not going to be a problem. But if it's a dynamic application where the production line is moving all the time, now we have to know how much data and how fast do you want to write that. Next one being architecture is, you know, how is my production line set up in general, right? There are many different ways. Not everything is just one big long production line. Many times there's a manual process involved in the middle of an automation process. There's, you know, specific robotic cells that have to be included in that process, et cetera. So it's important for us to know what that architecture looks like. Read-write distance, that's a huge one, obviously, and that usually is the driver that tells you which frequency we're going to end up going with. The tag and the reader form factor, again, this comes down to, you know, in some cases we're talking about putting medication into a tiny little vial. So the production line for something like that is really small compared to, let's just say, an automotive production line where you have tons of room and tons of space around the production line. But again, that's critically important because we have readers the size of, you know, a small box of matches, or readers the size of, you know, a 20 centimeter by 20 centimeter square. So there's advantages and downfalls of using each of those, and we can explain that to you. So, and again, and finally, the communication protocol. When it comes to the controls platform that Balluff interacts with, you know, we're agnostic in that world. So, you know, you think about Ethernet IP, Profinet, Profibus, EtherCAT, CC-Link, even TCP/IP, RS-232. We do all that, and that's critically important because that adds flexibility and scalability to your data collection. So RFID architecture, and I mentioned this, and you know, depending on your line architecture and all those other drivers, we would choose a system based on that. And these are our 3 most popular systems here. So, you know, IOLink, if you've not heard about that, you will very soon. Again, and usually IOLink is used in a case where you have very low data requirements and it's just standard speed. It's not, you know, high speed production line where things are zipping down the line and things are happening really quickly. Usually it's just, I have a license plate of data, maybe 4 or 5 bytes of data, and it's coming through at a standard speed. And that's just, and you can put an RFID reader alongside, you know, all your smart lights, your measurement devices, your standard sensors, et cetera. And I'll show you an example of that here shortly. And then, you know, our multi-frequency system. We can actually put LF, HF, and UHF all in one processor. In addition, there's an IOLink master port on there to add like a smart light or an indicator light, or even put like a 28 port hub off there that I have standard IO in. Again, it all comes down to your specific architecture on your production line, and we can match the RFID architecture to go along with it. One of our most popular systems lately is the all-in-one system. And again, this is designed for high-speed, high-memory applications. It's a very simple system to use. There's 3 ports on the bottom of that reader, and I'll show you an example here shortly. 3 ports at the bottom of that reader, and it's simply when you want to expand that reader from 1 to 2 to 3 to 100, it's literally just daisy chaining is all it is. Very simple concept. So going back to the IOLink concept and the IOLink architecture, this is what this is the thing in the middle is an IOLink master block, and that master block can accept devices of all sorts, right? So whether it be a linear transducer, an indicator light, a smart light, RFID heads, of course, all these different things can be put into one master block. Again, so you have sensors operating through the same block that you do RFID heads. You have a inductive coupling device that can actually change power from one device to another without touching, right? So in a case where you have like your high density plugs that have all these little pins that break off all the time, you can actually have non-contact power sent through that air gap, and even rotary tables, you think about that. But all these things can be plugged in to one IOLink master device. So the Bisv platform, again, I mentioned earlier, we can do UHF, we can do LF, we can do HF, and talk all these different communication protocols all in one device. And again, the advantage of that is eliminating the number of parts and pieces that you have in your plant, and eliminating the number of part numbers, and having the flexibility to essentially you can standardize on one processor and put multiple frequencies in multiple areas of your plant. And some people say, well, where would you do that? A big part of that is the machining process. In some cases where they'll have low frequency tags buried in the side of a tool holder, and in that low frequency tag, you write information, offset information about the tool. And then as that part would come out of the machining center, the transfer process usually is HF, or high frequency. So there's maybe two different tags involved, but it's no matter because I can read it with the same processor. So the all-in-one system, and again, this is available in Profinet and Ethernet IP, but a very simple concept. Like I mentioned, there's a power port, and then there's a two-port switch also built into this one compact RFID reader, and it's just a direct connection to the PLC. So in a case where you wanted to expand, very simple expansion, in that you literally just add power to each individual RFID read-write head, and then you literally connect a network cable from one to another. And this is big in automation, where you've probably seen single cell robot cells that expand greatly over time. This is really a system where I'm seeing this being used there, or what we call islands of automation, where you have a very manual process for a majority of the production cycle, and then you have some automation that happens in between there. And that's usually where this is used, because it's very easily expandable. A lot of our customers will start off with one reader and expand to 25 over a period of a year and a half. Again, because of the way they build out their production line, you can allow for traceability all along that process, and it's simple, again, very simple to expand.